Good afternoon, Tariq.
Good afternoon, sir.
Not about that, me say only much.
Somebody just called a while ago?
Oscar.
So I went through a past paper and did topic about trapezoid rule and so forth. So you hear me?
Okay, so good afternoon, students. I have waited and I'm not seeing any other student joining since. Um,
Good afternoon, sir.
yeah, how you doing? I love that DP, Mr. Courtney's. Jesus, I love that DP. I love that DP. I love that DP. All right.
Thank you, sir.
Yeah, no problem, hon. So you notice I didn't send anything last week because I mean, outside of the recordings, by the way, Mr. Crossdale, I don't hear anything from you from last week, Wednesday. I've been waiting to hear you say something, sir. What do you have to say, sir?
Real. So, sir. Yes, sir.
No, no,
Crossville
hold on,
or Crossville?
no, Crossdale.
Me, sir, you sure?
Michael Crossdale,
Yes, sir.
right?
Yes, sir. My
What
party's
what was the last thing you said to me at the end of class on
paid my
Wednesday?
class.
Huh?
Sir, remember I asked you about I think there was a question that I asked you, and you said that I asked the question the day before.
And then what? And then what happened? No, man, that's not it, you know. You said something about something, and I said, go ahead and say, but I did check and I didn't see it.
Oh. Okay, sir. I understand what you're saying now. The recordings.
What about them, sir?
Sir? I
What about
didn't get to go through them, sir.
But yet still you're rushing every day.
No, sir. No, sir. I have other stuff
No, but
doing.
the
I have
important
other
thing don't
questions.
make it. No, the important thing don't make it.
Yes, sir.
Are you seeing them? No answer?
Give me a second, sir.
My computer is dying.
Yes, sir. They're there.
Okay, I'm just checking. Thank you, sir, for confirming that they have been there. All right. So I didn't send you any. The only thing that I did was to upload the recording for last class, and I didn't send you any of the documents. And there's a reason why I didn't send you the document. To the point where I couldn't even go back to see what it is that I did last. So which is why I was asking for somebody to remind me.
Well, to be honest, sir, I thought you were going to be here because of the something that was going on today.
What does that mean? Jams?
No, the school this is about what was it?
Sports day?
Yeah.
No, sir. Clearly you don't know Mr. Shand. My teaching comes first. I'm first a teacher before a spectator. I apologize, but I'm not one of those. I remember before COVID, when we had sports day, they said that sports day is supposed to start at 10 o'clock. I'm ending my class at 10:15. All right, because students must know that exams are around the corner, and them can't go up on the paper go write say we had sports day. So I'm sorry. I love sports day.
Well, to be honest, I actually forgot about jumps.
Oh yeah, man, I love sports day and I love those stuff, but there are things to be done, and I have to hold myself accountable. Last weekend was a rough weekend for me with online classes. I had a rough weekend with my online classes. In particular Saturday, I had a 8 to 12 and a 1 to 5, and I barely got anything done up. So I mean, I know I have some makeup to do, and you guys weren't affected really, but I'm just saying it. So you don't have time for that, sir. But anyhow, I am a little concerned. Then, if I were to say the least, I'm very concerned that you guys weren't getting the trapezoidal the way I wanted you to have gotten it. And when I ended class last Wednesday, I ended class with quite a number of you, many of you even, um, were clueless, were very lost, had absolutely no idea what was going on. Didn't say all, but many. So as a result of that, I deliberately not send the recording, sorry, the notes as a test to see how many of you were actively jotting down in class and to see how many of you would have looked at the recording. And the recording for the recording on what it is that we did last Wednesday. And to my surprise, only 5 students looked at the recording that I uploaded.
So wait, say what's your view count?
Oh, absolutely.
I don't normally look on recordings. That's why I try to be present at school. I
And
don't like
and that's fine. And that's fine. Lotto, because I surmise that when I didn't hear the questions coming from you, so I surmise that you are not a recording person. You show up for class, and I mean it shows in your class participation.
Sir,
Yes, sir.
sir, but me on a recording person, sir. I like see work, so I can write it down.
Absolutely. No, absolutely. I know that. So I know the ones who speak up. I know the ones in the class who are the recording ones, and the ones who don't pay the recordings much mind. Because I mean, based on the questions that come to class, these are questions that you want the fulsome understanding. So I don't have a problem with that. But there are quite a number of other students in the class that do not speak to me. Those are the ones who I'm expecting to be looking at the recordings, and the analytics are not indicative um, of what I would have liked. But you know, what if you do? Anyhow, just to say, suffice it little that the last week was a rough one. I didn't like, if I were to be honest with you, I um didn't like the I didn't like the energy I was getting from you last class. But I am thanks for the opportunity. Oh Lord, why am I opening it again? I already have it open. I am giving God thanks for the opportunity to once again be able to go through what it is that we discussed. I'm going to ask you for today, though, that you give me your undivided attention and afford me an opportunity to go through the stuff with you. Again,
We can write down.
today is not a day when I'm going
Oh, sorry, you're muted, by the way.
Thank you, sir. And I'm not sharing again, all right? Hold on. Thank you, Papa, because I was talking to myself. So I was saying that today is not one of the days where I'm going to be pausing my class to ask who is understanding from who is not understanding. No. And I'm saying this deliberately on the recording, that whoever picks up this recording will get the sense that there are times in class I call upon students, are you understanding? And I get a zero answer, zero response. Tonight is not the night for it. Tonight is a night for me to help you to concretize the whole concept of the trapezoidal rule, to the point where I'm going to go back through May 2019 exam paper. If you are not understanding, and I'm saying this at the top of the class, yours is going to be the responsibility to ask me to pause. You will field your questions, I will answer them, and I will move on. Am I understood?
Yes, sir.
All right,
Sir,
thank
we
you.
can write. Yes, sir.
Say that, Papi?
Can write?
If who can write, me or you?
Me.
Yeah. Write what though?
Sir, the whole procedure we are gonna do, sir.
Yeah, man, they can write it, you know. I mean, I have it on screen, but if you want to, I will go very slowly because guess what? It's when I leave this thing tonight, it means that I would have left it. Now, hear what it is that, and this is how I often get myself into problems. Your mid-semester should have already been administered. I am delaying the mid-semester because I'm trying to give you an opportunity to go through the things that we have done before so that those things can become concretized. When you do well on your mid-semester, it affords you a greater opportunity to pass in my course. I don't like when students fail. There is absolutely no need for you to fail this calculus too. None whatsoever. I think I'm the most patient member that will go through this stuff and will go through this stuff and will go through this stuff. I'm not one of those who will rush you and create an environment where it is that you don't feel comfortable to talk. So I'm saying to you, if you have a challenge, field your questions. Tonight is a night for it. Even if I don't go through anything else, because it's when I finish trapezoidal, I've gone to volumes of rotation, you know. I mean, no, so when we reach volumes and rotation and finish my volumes of rotation, I have a few more topics to do to finish off the syllabus. That's where I'm at. Where are you? All right, let's go. So, as I said before, the trapezoidal is really not difficult. It really isn't difficult. I find though that if our mindset is not where it ought to be, we'll have a challenge in grasping the concept. So I'm going to ask you to just indulge a little bit more. Again, I'm going to ask you to put up a hand. Either your right hand or your left hand, it doesn't matter to me. I'm going to ask you to spread apart your fingers. I'm going to ask you to turn the palm of your hand towards you. The back of the hand should be away from you. I'm going to ask that you look at the palm of your hand. And I'm going to ask you to your thumb.
Sir, are you sharing screen? I'm not seeing.
I'm sharing.
Oh, okay, I'm seeing it now, sir. Okay.
I'm going to ask you to move your thumb up a little closer to your index finger so that Lotta doesn't have to say to me that don't look like one V. So when you put your thumb closer to your index finger, I want you to agree with me that you're seeing 4 V's. Yes or no?
Yes, sir.
All right. Each of those V's is representing a trapezoid. Therefore, how many trapezoids do you have?
4, sir.
4, sir.
Great. How many ordinals do you have?
5, sir.
5, sir.
Good. So each finger is representing an ordinal, and each V is representing a trapezoid. So you will recognize that you will always have one more ordinal than you will have a trapezoid. True or false?
True, sir.
Good. Whether or not they say to you that in the question, with X number of trapezoids or X number of ordinals, at some point in time in the question, you must make reference to ordinals and trapezoids. At some point in time in the question, you must make reference to ordinals and trapezoids because you're going to need your ordinals in order to do your calculations. You're also going to be needing your trapezoids in order to find out the width of the trapezoid, right? So ordinals and trapezoids You
No,
can't do the
would be
question.
everything between 1 and 4.
Yeah, right. So you can't, you cannot not do the question and not interface with trapezoids and ordinals. You must interface with your trapezoids. You must interface with your ordinals. You cannot escape dealing with the two. So you can't say to me, sir, I don't like working with ordinals because it means you're not going to be able to do the question. Guys, the question carry anywhere between 7 and 15 marks. Easy 1, 2, 3. Anywhere between 7 and 15 marks. No, those big boys, they don't play with, because it means that if you go into the exam and you see of the 3 questions, you see each of those questions have a big boy in there. And say each of those questions, them big guns, come at about 10 marks. And you can do those 10 marks at 30 marks out of 60 gone already, What that mean for you for the exam?
Yeah, 50% already.
50% already. 50%
And the weight
already.
ones.
Yeah, man. No, may not expect nobody to fail the multiple choice. You get 20 multiple choice questions, you must get at least 10 out of the 20. Nobody can get 9 and 8 and 7 and 6 and 5 and 4 and 3 and 2 and 1 and 0. You crazy?
Is it
No.
you're surprised with what people will do? So,
No. You cannot sit in my class and get a 0 on a multiple choice. It means that you
oh,
never
same
deserve to
in.
be in my class.
Oh,
Yeah,
same
man. You
in.
can't do that. The minimum you can get is 10. So right there and then you pass the calculus too. So which is what I'm saying to you, get the big boys out of the way first. And then when they get them out of the way now, the little ones them know, the little plebs, we come with a little 1, 2, and a little 2, 3 mark and so forth and so on. You just box them. That is the icing on the cake. So so you have your C minus already. And then you're working your way up from the C minus into the C plus, into the B minus, into the B. Then after that, you say, blow up, I find another little question. You can move to the B minus. And then you say, you know what? Got you. I have my A. Right? So I'm saying to you, you have to be strategic in what it is that you're doing. Please. All right. So here's the question. The sketch below represents the area under the curve y equal x squared plus 2 between x equal 1 and x equal 4 of the boundaries of a plot of land purchased by ABC Company. No, the part that were purchased by ABC Company is not of concern to you because you don't even know who is ABC Company. Matter of fact, you don't even know if an ABC Company exists. That's not your concern. What should really ride you now is that y equal x squared plus 2 and the x equal 1 and the x equal 4 because that is meeting up to something nice. But here it says now, the lengths of the particular offset at equal intervals, Rockstone. Once we speak about equal intervals, I'm speaking about my trapezoids. Once I speak about equal intervals, it is my trapezoids that I'm referencing. My equal trapezoids, I am referencing my trapezoids. Remember that, because your trapezoids are at equal distance. Your trapezoids are equidistant. Your trapezoids are equidistant. So once I speak about equal distance, you know so the trapezoids I'm talking about. So it says the length of the particular offset. The length of the particular offsets. Oh, so they call offsets the trapezoids. So the length of the trapezoids from the straight line to the curve boundary are shown on the sketch. All right. Then now we'll come to the question. Sir, what is the 1, the 1.5, the 2, the 2.5, the 3, the 3.5, the 4, the 4.5? Rubbish, there's no 4.5. Stop at 4. And I say to you, I do not know. And then you said to me, what is a 3, the 4.25, the 6, the 8.25, and the likes? And I say to you, I do not know. But the question says, the field manager of a company would like to know the area of the plot of land before using it. Now, we have been doing integration. You know that integration calculates the area under the curve. I have told you this before many times over, that integration speaks about the area under the curve, and which is why your answer has to be in unit square. That is the reason your answer is in unit square, because whenever you're doing square, it means that you're talking about area. Whenever you're talking about cube, it means that you're talking about volume. Press pause. I did say to you that my next topic is going to be volume of rotation. You see? Volume. So it means then that when you do our calculation for the rotation, my answer will be in unit cube. Why, sir? Because we're talking about volume. Unit cube, because I'm talking about volume. When I'm speaking about area, I'm talking about square, unit square. Then it says, and something written in bold, 1, calculate the area of the plot of land using the trapezoidal rule. Now, first things first, if you use any rule other than trapezoidal, you get 0, all when the answer right to the T. Why, sir? Don't is the answer we're marking? No, you don't even get a mark for the answer because you did not follow the instruction to the question. The question is about using the trapezoidal rule. So you have to use the trapezoidal rule. All right? Then you're going to ask yourself, what do I use in order to arrive at my intervals? And then you'll say, my upper limit is 4, my lower limit is 1, my upper limit is 4, my lower limit is 1. But sir, the question did not give us the number of trapezoids. I would agree. The question did not specifically tell you the number of trapezoids. However, the question referenced the sketch below. True or false?
True, sir.
All right. So if the question referenced the sketch below, it simply means that I must look at the sketch below. And the sketch below has 1, 2, 3, 4, 5, 6 trapezoids. The sketch below has 6 trapezoids. So I am going to use my n to be equal to 6. Sir, why? Okay. If the sketch below represents the area under the curve y equals x squared plus 2 for the boundary 1 to 4. And then it says to me that the offsets are at equal intervals. I know so the offsets there is going to be the trapezoids. So if I look at it and I see that, oh, there are 1, 2, 3, 4, n equals 6, sir. Excellent. N is going to be equal to 6. So from this here, I'm not going into part 2 yet, you know. I'm looking at part 1. So from that information, I know the upper limit, the lower limit, and what I also know is that it has 6 intervals. What I now know is that my v of x is going to be b minus a over 4 over n, which is 6. I can calculate that. So my v of x, which is going to be the width of my trapezoid, is going to be b minus a over n. B is the upper limit. A is my lower limit. And n is the number of trapezoids. So what I'm going to have is 4 minus 1, and 4 minus 1 is equal to 3 over 6. And 3 over 6 is equals to 1/2. So I'm going to have 1 over 2. I'm going to have 1 over 2. I'm going to have 1 over 2. That's my V of X. That tells me the width of the trapezoids. So each trapezoid is going to be equidistant from the one before it. Therefore, each of them will have a distance of a half. A question that Lotto asked, the same one that Mikey asked, Rockstone, go through that, is, sir, how do we know the ordinals? Let me say this now. Let me say this now. The width of the trapezoids, with the upper limit and the lower limit will determine the ordinals. We know we have 6 trapezoids. The number of trapezoids will be one more, or is one less than the number of ordinals. So if the number of trapezoids is 6, that means that we have 7 ordinals. If the number of trapezoids is 6, that means that we have 7 ordinals. So because in my headspace, I know I have 6 trapezoids, we know so we're going to have 7 ordinals. We know we're going to have 7 ordinals. So let us go.
Sir,
Yes, sir.
before you go, the top part, where you have solution, the long statement after that, we need all that, or we can start at the VX.
I just try the formula now. You know, start teaching, so I have to put the formula there so you can see. So what is it at first something we have? The integral of 4(1) x squared plus 2 dx. That's the formula.
Sir.
So if you know the formula, you can just move on to the V of X.
Yeah, that means if we can.
Yeah, man. I just put that there because I want you to see the formula every time we're doing this stuff.
And the 6 is the number of trapezoids, right?
Number of trapezoids, yeah.
All right, lovely.
All right. I'm not even going to go through that part of it just yet. Let me go back here. So we know that, the width of the trapezoid is going to be a half. You must always start with your lower limit, and you must always end with your upper limit. Sir, I don't know my starting point. Look on the limits. The lower limit will always be your starting point. Then, sir, what is the end point? You can't pass the upper limit. You know why you can't pass the upper limit? Because at that demand, them ask if you integrate. That's the area of the plot of land that you're interested in. So if you do a calculation that is outside of the boundary, you're wrong. That means, sir, they will always have to give you the upper limit and the lower limit. Duh. How you can find the area if you don't know the limits? It means that it's going to be an indefinite integral. So in order for you to calculate that stuff, you must have your upper limit, your lower limit. So we're going to start with your lower limit. 1. Where we jump to? We're going to jump to a half more than 1. Sir, why? Because your V of X, the width of the trapezoid, is a half. So we're going to jump 1. We started at 1. We'll add a half to 1. We are going to get 3/2, which is the same thing as 1.5, which is just a half more.
And then you'd add another half.
And then you add a half more.
And then you'd get 2. And then you
add a half more.
Then you get 5/2.
And then you add a half more.
Until they reach the limit.
No, say 3.
Yeah, 3.
And then you add a half more, you get what?
7/2,
which is 3.5. And then you add a half more. Then you're going to get your 4, your endpoint.
Sir, quick question. Does it matter if you write it in a decimal point or fraction?
Okay. Thank you for that question. It does. If you have a terminating decimal, it does not.
Sir.
If you have a terminating, I'll come into you, let me just finish your thought. If you have a terminating decimal, it doesn't matter. What is a terminating decimal, sir? And decimal that ends. The decimal that ends. So give me an example. 1 over 2. When you calculate 1 over 2, you will get 0.5. There's no other number after the 0.5. Another terminating decimal is 3 over 4, which is 0.75. After the 5, you don't have any other digit. Another terminating decimal is going to be 2 over 5, which is 0.4. You don't have any other digit. A recurring decimal, on the other hand, is like 1 over 9. You're going to have 0.1, 1, 1, 1, 1, 1. So that 1 is a recurring decimal. Like 2 over 3, 0.66666. So once you see that the decimal is recurring, you are not allowed to use the decimal form, because you are approximating your decimal, your fraction, sorry, to give you a rounded decimal. You're approximating the decimal form. But remember, the trapezoidal rule is a method of approximation. So if you approximate a section of the question, you are approximating the approximation. So you approximating the approximation means that your value, your final answer, is going to be off, because already the approximation is going to be an off number. It's not going to be the full value. It's going to be an off number. Am I clear right there?
Yes, sir.
Okay. So what I'm saying to you is, if you're given a fraction, if the fraction does not terminate, please work with a fraction. If the fraction terminates, then go ahead. Like in this case where I have the 1.5, yeah, man, you can put in the 1.5 because you don't have any other digits. So what you're not doing is approximating. So nobody can accuse you of approximating the approximation. And you should be good to go.
Okay, sir. Thank you.
All right, so thanks for the questions, for rolling in. I appreciate those. All right, so let me continue now.
Sir, can pause. You know, can pause that, sorry.
Go ahead.
Yeah, I mean, if you understand the part where you have Vx over 2.
All right, I don't reach this yet. I'll soon come to there. You notice I jump over it?
Sir, I can't talk so much with me and laws with it.
Hey, Papa, remember, around revision, they said, no, we're supposed to catch this from last week, but I jump over that for a particular reason. I jump over that for a particular reason. Yeah, man, I soon come back to that one. So we have now evaluated our ordinals. We know our ordinals. And we know, so we have 6 trapezoids, so we have 7 ordinals. We know our ordinals. 1, 1.5, 2, 2.5, 3, 3.5, 4. And when we look up on the diagram, we see we have them down here. So 1, 1.5, 2, 2.5, 3, 3.5, 4. We have them. We see it. We don't know where them 3 and 4.25 and 6 and 8.25 value come from, But we know, so the curve here, so is representing y squared plus 2. But we just don't know where them number here now. We figure out to the 1 and 1.5 and them something they come from. But we are trying work. Let's go. We know that the trapezoidal rule is not asking us to do an actual integration. We know that the trapezoidal is not asking us to do an actual integration. It is only asking us to do an approximation. It is only asking us to do an approximation. And we are going to be doing this approximation now. So what is the approximation? You see, each of those ordinals, you are going to be substituting into the original function. So what is the original function? The function given. The question would only give you one function. So we're not going to give you two functions to confuse you. Y equals x squared plus 2. So anywhere in the function you see x, you are substituting the ordinal 1 and you will evaluate it. So let's go. Anywhere in the function I see x, and I apologize, I'm not able to lie. All lies. I'm able to, but do I want to know mark up this thing? What the heck? I can. It's mine.
Oh, so excuse me for me.
Sure, Papa. All right. So it's because KC winning champs. Let me use KC colors.
Sir, what you going on with here? Sir, use blue, please.
Father friend, I give you thanks. All right, then, cool. Now, so another word. So this is it. Anywhere in the function, hey, I could use a different writing something. Anywhere in the function, right here, so I see x. I'm substituting my 1. So therefore, 1 squared plus 2 is going to be equal to 3. Because 1 squared is 1, and 1 plus 2 is 3. We write only 3. We'll move on to the next number, 3.5. 3 over 2. Right here, so. Anywhere in the function I see x, I am going to put 3 over 2. So 3 over 2 squared plus 2. A disclaimer. You see, anytime you put in a fraction into your calculator like that, I want you to be using your parentheses. So you can open your parentheses. You're going to open your parentheses. And when you open your parentheses, you're going to press 3 divided by 2, close the parentheses, and then you square it. Lotto and I think one other person in the class can write it in their natural form as 3 divided by 2. The rest of you, what I want you to do is to open your parentheses. And when you open your parentheses, you're going to, having opened your parentheses, you're going to then press 3 divided by 2. Then you're going to close your parentheses. When you close the parentheses, it is at that point you're going to square it. And when you square it and add 2 to it, I promise you, you will either get 17 over 4 or 4.25. 17 over 4.
Yeah, we get 4.25.
And it is the same thing. So you don't even have to write 17 over 4. If you write 4.25, I give you full marks. So we finish the second ordinal point. We're going to the third ordinal point, which is 2. Anywhere in the function you see x, you're going to put 2. 2 squared plus 2. 2 squared is equal 4. And 4 plus 2 is 6. Yeah, man. Then the next ordinal point is so quickly I move the whole number 1. The whole number 1 is not a problem, you know. And the fractional one gives people a problem. So we're going to move to the next ordinal point, which is 5 halves. 5 over 2. Anywhere in the original function you see x, you're going to put 5 over 2. Open your parentheses. 5 divided by 2. Close your parentheses. And then you square it plus 2. You're going to get 8.25 or 33 over 4. then I move to my next ordinal point, which is 3. And when I put my 3 here, anywhere in the function I see x, I'm putting 3. 3 squares plus 2. But we all know that 3 squared equals 9. And 9 plus 2 equals 11. So I'm going to have 11 there. And then finally, we're going to use the 7/2. Anywhere in the original function I see it, I'm putting 7/2. Right here, so. Says open parenthesis, 7 divided by 2, close parenthesis, all squared plus 2. I'm going to get 15/7/4. Or it's going to be 14.25. And then the final one, anywhere in the function I see x, I'm going to put 4. And 4 squares are 16. 16 plus 2 will be 18. Then, sir, we have to get all of 7. Hello. Whatever amount of ordinals you work out the question to be, that's the number of stuff you're going to do. The more ordinals you work out, it means that the question is going to be longer. And more marks the question carry. So them give a question with 4 ordinals.
That's a 20 mark question, right?
This one is not a 20 mark. Yeah, this one is a 20 mark question. I think. Yeah, it's a 20 mark question. The more ordinals you're asked to evaluate, the more points you get for the question. So if you get a question with 4 ordinals, expect to get about 10 marks for that question. And also expect your final answer to be a little further off from the actual answer. Because the more trapezoids we have, is closer we get to the actual answer. That's a multiple choice question. Because the more trapezoids we have, is closer we are to the actual area. Is the more we are to the actual area up to the question. All right. And then now, I'm going to jump back up to what Bijan asked earlier. I am now going to be talking about this Vx/2. Every single time you're going to be using that formula Vx/2. The width of the trapezoid is going to be divided by 2 to give you this value. It's going to give you that value. All right. Now, that value there, 1/4, is going to be very important. If you forget to calculate the width of the trapezoid divided by 2, your V of x/2, the question is going to be wrong. So I'm going to ask you to always remember it. I do it because I don't want you to confuse the V of x with the V of x/2. So which is why I said that I'm going to do it right on here. So when you finish all of this calculation, then you can go ahead and do your V of x/2. Look at what happens. You see this 3? See it right here, so. You see this 7/4? It's going to be 2 of them. You see this 33/4? Are going to be 2 of them. You see this 11? It's going to be 2 of them. You see this 6? I left out the 6. It's going to be 2 of them. The 57/4 is going to be 2 of them. But the 18 here is going to be one of them. Put up back the palm of your hand again for me, please. Put up back the palm of your hand again for me. And allow the palm of your hand to be looking at you. The palm of your hand to be looking at you. I'm going to ask you to squinch up that thumb closer to the index so it also looks like a V. So it don't look like one C. All right? Now, can you agree that the middle finger, can you agree that your index finger is sitting right between two fingers, your thumb and your middle finger? Yes or no?
Sorry, go again. You mean they're between two?
Hold up the palm of your hand in front of you. Look upon your index finger and tell me if your index finger is sitting in betwixt your thumb and your middle finger.
Oh, yes, sir. Yes, sir.
Yes, sir.
Okay. All right. I'm hearing you now. All right. Can you agree with me that your middle finger is sitting between your index finger and your ring finger?
Yes, sir.
Can you agree with me that your ring finger is sitting between your middle finger and your pinky winky?
Yes, sir.
Yes, sir.
Which two fingers not sitting betwixt any two something?
Thumb and the little finger.
Thumb and the little finger.
The first one and the last one, don't it?
Yes, sir.
And that's why the first one is not being multiplied by 2, and the last one is not being multiplied by 2. The one here is not being multiplied by 2, and the one here is not being multiplied by 2. Why, sir? For the example that I just showed you. But now say it again. Come and think that is self-explanatory.
Yes, sir. That's clear.
All right. Somebody asked a question last class. Sir, am I allowed to just add up all of the middle finger them, all of the fingers them where come betwixt two fingers, the index, the middle, and the pinky winky? We can just add up them 3 values there and then multiply by 2. The answer is yes, but risky. What I prefer you doing is writing it out. So me can see it. It lessens the chances of you making an error to getting the question wrong. All right? When you do all of that, you should end up with 217 over 2. And remember your v of x over 2, very important. Your v of x over 2 is very, very, very important. You cannot not have your v of x over 2 multiplied by that number. And sometimes your v of x over 2 don't come as a 1 over 4 as this one. It can come as any number, 2 over 3, anything it can come as. All right? So when we do all of that, we're going to end up with 27.125. And that will give us the area under the curve by approximating it. It's a quick approximation. And we'll get the area under the curve like there. So we don't write the same now. It's not for you to ask me your questions. What questions do you have of me? Am I clear as mud?
Sure, when I zoom out so far, we can't really see because my right hand kind of blurry.
I did it because, again here, sir, you can scroll up, you can scroll down. But since I'm not hearing that, I can't do this.
No, that's too far. Zoom in, zoom out a little, please. All right. Yeah, and then scroll back down.
Sir, my question now, sir. When we do that question here, because we know the question I finish. All the steps them from here. This is how it normally be. In terms,
Yes, I.
all right.
Yes, I.
So you divide the upper and you minus the upper from the lower limit over the amount of fingers. You call it ordinals.
Actually, the lower from the upper, the other way around. The minus the lower limit from the upper limit. But go ahead.
Yeah, bigger one minus one. And then over 2. You see that over 2 part there, sir? Fx over 2.
Hold on. Are two different something you just talked about a while ago.
No, after you do the v of x itself, yeah, I understand. X, yeah.
Right.
Then you move to the v of x over 2.
Yes, I.
Right.
Yes, I.
See that? What kind of show me about the half there over 2?
All right, hold on. Let me put in my. I hope it don't give me any. I hope it behave like a good little Christian.
One more question, sir. When you do this, it better you work with the fractions, I mean, better.
Okay. Yes.
May I ask if it better, sir?
Oh, for me, I don't. Oh yeah. Work with the fractions, yeah, man. Yeah. I thought you said decimal. Yeah. By far, yeah, man. When you work with the fractions, it catch everything. You know what? Miss out nothing, Rockstone. You know, so you don't understand, teacher Sean. Oh, if you carry your writing implement and have a pen for write with it. Hold on 1 minute, guys. I just want to show him something because this question was asked of me last week as well. And I want to make sure that I catch it. Hold on half a second. I have the pen right here, sir. And I couldn't find it. All right. Let me just get it. So what I have, Bishon, is a half divided by 2. And that whole number is 2 over 1. I have a half divided by 2, which is really 2 over 1. 2 is the same thing as 2 over 1. When I'm dividing two fractions, I'm going to invert and cross multiply. All right, let me show you what it is that I'm doing. Because when I was going to little school, this is what teachers told me. Me never understand what it mean. Me to just do it because teacher said must do so. All right, watch me now. Your aim is to get your denominator to be equals to 1. Why, sir? Because anytime you divide a number by 1, you get back the same number. So your aim is always to get your denominator to be 1. Now, in order for me to get 2 to become 1, let me do it like this. No, let me keep it like that. In order to get 2 to become 1, I'm going to be multiplying by the reciprocal. So we shall multiply down here so by a half. 2 halves make a whole. But since I multiply down here so by a half, I have to also multiply up here so by a half. So what I'm now going to be left with is 1/4 divided by 1. And when I divide any number by 1, when I divide any number by 1, I get back the same number.
Yeah.
So I'm going to end up with a quarter. So that's essence what you do when them say to you, invert or multiply. That's what it means. Invert or multiply is just multiplying by that. That's exactly what it means. Any question?
We get it now, sir. We just that's it. If the for instance me in an exam and we calculate a malfunction, how to fix it.
Say it again, Bijan. If you're in an exam and what?
The calculator malfunction. One over do it by himself.
You can do it. You can't. You don't have to use my calculator to do this, puppy. You don't need a calculator to do this, man. Look how me just do it a while ago without the calculator. Don't doubt yourself, man. You can do it, man. Don't doubt yourself. Hello?
Yes, sir.
Yes,
Yes.
sir.
Okay.
Yes, sir.
All right, cool. So that's what it is. There's nothing more to it than that. The last part of the question now says, if by direct integration, the exact answer is going to be 27, find the percentage error in your answer to one above. That is the formula for the percentage error. E trap is the error for the trapezoidal. E trap is the error for your trapezoidal. E trap is the error for your trapezoidal. E trap is the error for your trapezoidal. And yes, you have another formula that you have to go memorize. What is that formula? K times b minus a cube all over 12n squared. Not every time them give a trapezoidal, them answer to calculate the error. Not every time they give a trapezoidal, they answer to calculate the error.
Oh, sir, that me just ask. Are this the next step or this one step down the line?
That's a different question. That's a different part. This is part 2 of the question now.
So, well, understand. Well, pause my brain. So we done part 1 of the question?
Yes.
So the answer where we get the
27.125.
Mm-hmm. That part of the question they done this, so.
Yeah.
All right. Right. So I go to the second part now. All right.
Yeah. I can move on, Bijan?
Yes, sir. Yes, sir.
Okay. So now, that's all you have to do, you know. You just have to now remember the other form, this formula. E trapezium is going to be equals to K times B minus A all cube over 12n squared. It's on every question them give you in the stuff them ask you about the error. So you may go into the exam and you may not see a question on error. You may just very well go into the exam and see a question on error. All right? Hear me now. What is K? In order for me to calculate K, I need to do my second derivative. All right, let us do the easy one first. B minus A is going to be your 4 minus 1 to give you 3.
Okay.
You know that your N is the number of trapezoids. Your K now. So you know what N is, the number of trapezoids. You know what B minus A is. We just need to work with K. K is going to be the differential. So remember, if f of x is equal to x squared minus 2, it means that f dash of x, which is the first derivative, when I differentiate x squared plus 2, what do I get?
2x.
Yes, 2x.
When I find the second derivative of that, what do I get?
2, sir.
Okay.
Remember them telling you now, note. F double dash of x. The absolute value of f double dash of x is going to be less than or equals to k. So all I'm doing is just substituting to the formula. Anywhere I see k, I put 2. See it right here, so that's a 2. And then b minus a is 3. See this 3 there? And it is always cubed. And 12 times the 6, all squared. You work what BOMDAS. BOMDAS says brackets of multiplication and division before addition or subtraction. In big school, I like using PEMDAS, PEMDAS. Are the same difference, you know? Parentheses first. You see, big word, same thing as brackets. Exponents. Multiplication and division before addition and subtraction. So I'm going to be looking at my parentheses and my exponents. These are my parentheses and exponents. These are my parentheses and exponents. So I'm working my parentheses and my exponents first. So 3 to the third power is going to be 27, which is this one here. You notice I care about the 2 right here, so. And the 6 squares is 36 here, and I care about the 12 right here, so. Then I multiply 2 by 27 to give you 54. And 12 times 36 is 432. And when I reduce all of that, I'll get 1 over 12, 1 over 8, sorry. When I reduce all of that, I get 1 over 8.
Okay, sir, I understand.
And that's all that there is to it.
So
Did I give you that example? Go ahead. Sorry. Did I give you that example that I just put on that I just project right there? Use trapezoidal rule to
No,
estimate.
sir. No, sir.
All right. We're going to attempt that one. We're going to attempt that one. Let me just do something here for you. That's what that is here. D of x over x is the same thing as 1 over x dx. Remember, your dx is telling you what it is that you're integrating the function with respect to. So you're integrating the function with respect to x. So when you say the d of x up there, when you say the d of x up there, that's not supposed to be there. But I can write it like that because remember, it's d of x over 1. D of x times 1 is d of x, and 1 times x is x, right? So I can separate it. I can separate it. I'm allowed to separate it. All right? But we just write it as d of x. So if you go into the example argument, say, can say d of x over 1. Don't say sir never teach you that. Just separate the d of x by pulling it out one side, then we're going to have a 1 over x.
1 over x times dx over 1.
Yeah. Or can I say 1 over x times d of x? All right, do me a favor. I am going to project. Write the question out for me first, please. You notice this question never asks about an error. It does say use trapezoidal rule to estimate that with 6 ordinals. How many trapezoids?
6.
5, sir.
Very good. I heard that 5. Very good.
And ordinal will always be 1 more than the trapezoid.
Yes, I. Start for me, please.
5 ordinals. 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 5 ordinals
Sorry, can you scroll back up, please? Up to the question, the second question, sir. No, sir. Up. Let me see the question that's asking. Yeah. You can scroll back down, sir. To the second part of that question.
Wait, hold on, sir. Go back up. Yeah, I mean the solution part, sir. With the formula. Yeah, right there.
Finish, Kazel?
Yeah.
Sorry, can you scroll down, please? Okay, sir.
So you there? All right, sir. So that part there where we get this second question. All right, hold on. Let me. And you pay asking sir a lot here, and you pay that to encourage. No, there.
Question, please. Let me see
Say
something.
it again. Go back to the question.
Yeah, the first, not the second, not the question that we got to work. The first one. Yeah, stop right there, sir, please. Right, so you can scroll go back to where you were before. Finish.
Sorry, you can quickly explain about the second solution, please.
That piece there.
Yes, sir.
What's the formula? Tell me the formula.
It's K bracket B minus A cube 12 and the number square.
Okay. So all you know what B minus A is, because you'd have done B minus A from up top. You'd have done B minus A from this line right here. So the 4 minus 1 down to give it that.
Oh, that's 3.
Yeah. And you know what n is? N is the number of the trapezoid. The only thing that you need to find out right about now is a K. And how do I find K? I'm going to find the second derivative of the function.
Okay, so yeah, I'm gonna get it. I see it now.
Okay.
Can you ask me on the right track?
What you want to show me, Papa?
I say more on the if we on the right track. All right. So for the second question, right?
Mm-hmm.
So
For the second question, in terms of this part here that is projected?
Basically. No, man. The second question is second, yes, right here, so.
Mm-hmm.
So basically we're going to say right then. We're going to put 1 over x in a bracket with the x outside, the dfx outside.
Mm-hmm.
All right. So then the v of x now, it will go be the 3 minus 1 because of the limit there, so. Over 5. It says it have 6 ordinals, but if it have 6 ordinals, that means it have 5 trapezium.
Very good.
Right. All right. So that equal the 2 over 5. And then the v of x over 2 would equal, because you're going to divide it 2 over 5. So by 2 or by 5? Oh.
By 5, sorry.
Yeah. All right.
And then maybe have 2 over 5.
Yeah. Divided
by 2.
I get 1 over 5.
As 2 over 5 multiplied by 1 over 2. So you can end up with 1 over 5.
All right.
Very good.
I'm sorry, it is 5. I didn't say anything, sir.
Oh, okay. Again, I'm going to tell you, it is not difficult. And I don't want nobody to say, yes, sir, you are teaching, that's not difficult. I'm telling you, man. When we get to the difficult topic, me tell you, say this difficult, you know. I am honest like that. When it's difficult, me say, nope, this one is difficult. Trust me. And this one here, and trapezoid are nice. It nice freight. Nice of a topic for learn.
You know, see my problem I know, so all right. So this never have no length. Oh, no. Interval length, right?
What is the interval length?
That really I think more.
No, tell me you have it on the screen. Right here. You just
So it can go by.
You just told me about it a while ago. What is the length of the interval? Somebody help him out, please.
What is it, sir?
By what?
The 1.5 there?
Huh?
The 1.5?
No. Which 1.5?
1 over 5?
No. What? You're not learning something.
1 over 5.
No.
No. Wait, yet at the interval, sir?
That's the width. 2/5. So it is going up by 2/5.
I thought I'm going to find it. Oh, so this right there.
You see, hold on, Bijan. You understand why I never want to calculate this part just yet? Because we end up with 1, 2 calculations. I may use the wrong one. Remember in the question, I said to you that. Yeah, so, you notice what I did was to jump over. I jumped over this section right here. So anybody remember?
Yes, sir.
Yeah, sir.
Yeah, because we have a half and then we have a quarter, and I don't want to get confused which to use. So that's why I jump it over there. So, and then when I got to this point down here, so when I needed to use this quarter, I made reference of the v of x over 2.
Sir,
very important.
At that time, probably with me, you know, you see, with the jump where you jump over it, sir, at that. So now me know, say, me use that piece here to increment it.
Mhm.
All right. All right.
Term of problem or increment, I get the interval.
Can't. 1 is the first ordinal. Then we add 2 over 5 to that. Then you get that answer. Then you add 2 over 5 to that. Then you get that answer. You add 2 over 5 to that. Then you get the answer. You will continue that process until you reach 3. You must reach 3. You can't pass 3.
No, you reach 3.
You don't reach 3?
No, I said you reach 3, sir. That's what I said.
It have to reach 3 because you just increment it. What it is that you've done, you have found the length of your interval. And having found the length of your interval, which is going to be 3 minus 1, which is 2, you have found the length of your interval. Then you're going to divide that interval now, that length 2, by how many pieces you want. So it must end with 3, can't pass 3. Or it can't be 2 point something, and then when you add one more to it again, you get 3 point something because you just set it up in a way there. So you must get 3. Promise you, real talk.
All right, sir. Work it now.
All right, man, ask the class now. If Camille want to get it right here. The intervals they want to get are 1, 7 over 5, 9 over 5, 11 over 5, 13 over 5, and 3. That's what we get.
Mm-hmm.
All right.
Yeah, we'll confirm that too. Yeah. See ya.
All right.
Never be alone.
Yeah, Bijan.
Oh,
Yeah. What you say again? 1, 7 over 5, 9 over 5, 11 over 5, 13 over 5, and 3. That's what again?
yeah.
We get the same thing.
And then when you do the workout part, them invert. Except the last one you get 1 over 3. If you understand me.
All right, thanks.
Right. Reach on portfolio, sir. Anybody else reach the calculation part?
Kind of stop.
Sir. They're gone.
No, man, I just couldn't unmute. I'm here. Yes, what one?
All right, sir. So we come so now and find the length, right? Then the next equation would be the limit 1 over x dx equal 1 over 5. And you open the box bracket. You call that box bracket. A box bracket there. You need a parentheses, I call it.
No. A parentheses call?
All right. You see function there right at the base of the screen. So we have 1 plus 2 times 5 over 7 plus 2 5 over 9 plus 2 5 over 11 plus 2 5 over 13.
So are you agreeing with me up to that point?
Yes, sir. Yes, sir. We discussed that part there.
Okay.
What going on? Hold on there, sir. Hold on there.
Sir, hold on, sir.
Hold on there. Top there. Hold on there, sir. All right, yes, sir. That means me do whole pass it wrong, yes, sir.
Remember now, at this stage, when you get your ordinals, you are going to substitute your ordinals into the original function.
Yeah, but sir,
No, that's not it, sir. That's not it. That's not it. I didn't realize.
Don't get that two there.
Also, inverse them.
So actually, I'm doing this part inside of the formula.
Oh, okay. Sorry. Sorry.
Sorry.
I'm sorry.
Sir, big guy.
No. Hold up.
No,
What I did was to incorporate my tools from here and here and here. So I apologize. So what you should have gotten, so I apologize. So let me just jump to this other line. Did you get 1?
You said we get 1, yes.
Yes.
You got 10 over 7?
Yes, sir.
10 over 9, 10 over 11. Check to see if you get this line for me, please.
All right.
Courage.
All right, hold on there, sir. Hold on there. No.
Sorry, I apologize.
Okay.
My step is correct, but it's just that
you do it from up there, so.
Yeah.
So you're frightening me. Sir, hold on there, man. Come here, wonder. Sir, all right. You see for that last limit there, sir, the 1.3. You see up in the example before it, you times it by 2, you know. The example what up. I mean, remember. Remember, you said the first ordinal, and last one of the times by 2, no, so.
See here? That's what
I said.
No, I mean the up in the first example where we do together a while ago.
Big take right there.
Yeah, the first one and the last one is not times by 2. See here? Them 2 asterisks are not times by 2. Other one, them this one, and this one times by 2. So I'm still doing the same thing. So the first one and the last one are times by 2. Courage, did you get this for your? Did you get 1.11 unit square?
Sir, I haven't calculated it.
Sir, see, at that part, I know me that wonder. Cause of this, me get.
So I was still thinking what I was supposed to do there. I don't know what's supposed to happen.
I had a opportunity, just that I forgot to inverse them when I was supposed to multiply them by 2.
Sir, all of my fraction if you get. You know what? More than time fraction sign.
You know the problem is now with a number of you is not the concept now in the trapezoidal, is how to manipulate your calculators is a problem now.
Yeah.
Sorry, can I scroll back up a little, please?
Sir?
Mm-hmm.
Sir, when I converted mine to decimals, I still got the 1.1.
Oh, yeah. You can convert to this one now because 2/5 is going to be equal to 0.4. So you could use this one. Yeah, so you're correct. So you're okay with my answer then?
Yes, sir.
Very nice, Joe. Lotto, you're silent. And the rest of you, I'm only hearing a few.
Sir, from you hear me silent, you know me, I try to figure out what is going.
Talk truth. Is Andre Francis in class tonight?
May I try to figure out it, sir? Can you say put it in the original function, man?
Yes, sir. The inverse part.
Yeah, that part.
That throw you off, sir.
What is turning you off?
The inverse thing that
The
you did.
inverse part, forget the function, sir.
Which part? This part here?
The
No, sir.
the ordinals to be
Ordinals
put
part, sir.
originals.
Sir, we get all of the ordinals.
Interval lengths are as follows. Those.
Remember, you know,
times
remember,
by
you know, what you have is going to be 1 divided by
7/5.
No, 2/5. No.
Oh, no, the ordinal.
1 would be 5/5 plus 2.2.
Oh, no. It's going to be 1. It's going to be 1 plus 2/5. Don't.
Yes. And that would be
one is the same
No,
as
sir.
5/5.
Another the problem. Sir.
The function,
sir.
You get the 1/1.
Ordinal into
When
the
we find
function.
7/5, yes, sir, that is clear. We find all of the ordinals.
Yes, sir, we find all of that, but the original function,
ordinals
sir.
now into
So
the
you're substituting the ordinals into the function.
Yes, sir. The function we are trying to get, sir. The function we don't understand how you get it. That's what them ask. That's what we ask.
You understand the one. You understand me substituting 1 into 1/x and get 1, don't?
Yes.
Okay.
Okay.
1/x.
So f of 7/5 now then is what it is that you have a problem with.
Yes, sir. So we know 1/1.
1/7 divided by 5. In order to get this to be 1, you have to multiply by 5/7. So you multiply up here by 5/7. So the answer is going to be 5/7. See here?
We multiply the both of them.
So it's 1/7/5 times 5/7.
So pretty much what you're doing, you're inverting all of them, inverting all of them.
And so you only do this for like improper fractions?
Yeah.
That's what I want to know.
Okay.
All right. So on your calculators, we have the 1/x function. Normally it is placed to the top left-hand corner, somewhere about there. So put 7/5, 7 divided by 5.
That's okay for me, sir.
Huh?
Start it over for me. What you're saying about the calculator.
So I'm saying to you, the 1 over x, the invert function, is normally to the top left-hand corner of your calculator. So what I want you to do is to put the function, put the ordinal in there. 7 over 5. And then we're going to press the 1 over x function. You may have to press second function for some of the calculators. And then you press equal and tell me what to get.
Is it 1 over x, sir?
Yeah, look for the 1 over x. So you can put 7 divided by 5 in the calculator. And then you can press equal. And then we're going to press the 1 over x button and tell me what to get.
0.714285.
Press shift ABC and tell me what you get.
Shift ABC.
Talk to me now.
Answer I'm coming. Shift isn't on
Sir,
my...
which one are we working out? Which one is it we're working out? The one with the 2 and the 5 over 7?
Say it again, Mikey.
So is it the one with the 2 and the 5 over 7 we're working out?
Wait, say ABC?
Yeah. No. Yeah, that's the one I'm working out.
So I got 10 over 7, but my calculator is a bit different. Let me take a photo and say.
Right, because you're going to multiply that answer now by 2. So you can get the 10 over 7. Now you are correct.
Sir, look into check the group, sir.
Yeah, man, your calculator. Yeah, you have a good type calculator. Yeah, Crossy?
Yes, sir, I heard.
Yeah, man, you have a good type calculator, man. The rest of you don't figure that out yet. This is not trapezoidal, no, you know. This is calculator working out.
The shift function is done by calculator.
It's supposed to be.
I get 5 over 7.
Yeah, you have to get 5 over 7. All right. 4 minutes past 7. I know you have a class. Do me a favor. I'm gonna send this off plus the solution from last Wednesday's class tonight for you. I want you to go to your other class and promise me that you're gonna spend about 10-15 minutes after your second class just to work out, just to appreciate the fractional working out. And then if you're still having a challenge, just send something in the group, because more chances are I will be up. Just send something in the group and I'm going to see if I can further explain it for you. But I thank you for getting this far. Yes, mommy.
Sorry to cut you, but when I did it both ways and I got 2 different answers.
Well, the other way that you get a different answer than the 0.111, throw it away there.
Sir, the fractional way I use and get that answer.
No, it means that you're not putting in the fractions in the Remember, students, when you're putting in your fractions in your calculator, always use your parentheses.
Sir, I did.
Well, something go wrong. Your big finger touch something else. Because if you use a fraction, you're supposed to get it.
3 times.
Try it again, Joe. Try it again. All right, I'm going to end here. I know you have another class. Please don't let tonight pass because we're going to come tomorrow again. Don't let tonight pass with this. Don't carry over this business come for tomorrow. Let us sort it out tonight so tomorrow we can build on something else. That
Sure.
sounds like a plan? Yes, Crossy. Yes.
Yeah, beg you, sir. Send it something them out so we can.
I can send them. I can send them, but all right, let me see if I can do it from this thing. All right, give me a few. I need to go stretch a little bit. Give me a few and I'll send it off to you. All right?
Yeah, man. Before you go, sir, the mid semester, I see. I can't, what you call it?
Educosa. We're not upon Educosa.
That's where I go do exam, man.
That's where I started put it the last time. So
chances are. But I'll talk to you about that. I'm gonna upload an exam paper, and you download the paper, and you do the work, and you then re-upload it to Edico.
No, that can't work. We rather write, man, because that stress me out.
You are going to write. But as I said before, let me explain the process first before.
Yes, sir. And tell me the topics that we're going to get to and then something.
No problem, we'll do. All right?
All right, sir.
Have a good one. Cool.
You